Hartlepool to find out how this murky-looking seawater can be made into a tropical environment fit for sharks. And it all happens in the Sea Life Centre, just over there.
Inside, there's a spectacular collection of sea creatures from all over the world living in huge tanks. Some species are from the coastal waters around Britain, like these huge cod and bass.
And there's some really weird stuff through here.
Around the corner, the creatures become more exotic. These normally live in the tropics. The tropical sharks are the big attraction, living in a tank the size of a swimming pool.
Shark.
Whereabouts do they live in the wild?
These sharks come from mainly tropical waters. Some of the guys in here are from the Mediterranean. Others are from places like Florida.
Not all sharks are dangerous. The basking sharks, which live in the seas around Britain, are harmless. But these fellas are a totally different kettle of fish. Paul, our diver, needs to be very careful indeed.
What do they need to survive?
Well, these sharks obviously need water. They're tropical sharks, that means the water needs to be at a certain temperature. And this water is heated to approximately 24 degrees C. They also obviously can't survive in fresh water, they need seawater.
The tanks hold huge amounts of it. In total, the Sea Life Centre needs around 20,000 litres of the stuff every day. And the easiest place to get it from is the sea, just over the road. But it's far from clean.
So how do you turn this into lovely clear water like you're swimming in?
Well, this water is passed through a series of sand filters, which takes out a lot of the dirt and bacteria, etc. The water's also passed through what's known as ultraviolet filtration, and that also helps in this process. So what you've got at the end of it is this lovely crystal clear water which fish are happy to live in.
Pipes run from the sea under the beach directly into the basement. The first thing that happens is that it flows through tanks of clean sand to remove any dirt particles. It's impossible to see what's happening inside, but on a smaller scale, it's easy to make your own filter. All you need is a tall funnel packed with sand. Murky seawater has lots of particles floating around in it. To get rid of them, just pour the dirty water onto the sand and wait for a few minutes. Any large particles are trapped by the filter, and clean water drops out at the bottom. It's now much clearer, but is it pure? What else is in seawater? Place a small bowl of seawater on a hot plate. Heat it up and the water evaporates. As the water disappears, what's left behind? Seawater contains salt. You can't see it, but that doesn't mean it isn't there. Add salt to water. Give it a stir and it seems to disappear. It dissolves. Together, salt and water make a solution. Sugar dissolves too. With a bit of a stir, these coloured sugar crystals will eventually disappear. Although the water takes on a slight yellow colour, it's see-through. Solutions are never cloudy, they're always clear. So, what's going to happen with chili powder? Even after stirring, you can still see the chili powder suspended in the water. It hasn't dissolved, so it isn't a solution. This is jelly powder. The crystals soon disappear. As the jelly dissolves, the water becomes coloured, but it's still see-through, so it must be a solution. To understand what's happening, you have to imagine that everything is made up of particles. In every jelly crystal, millions of tiny particles are held together in a fixed shape. They don't move around, they just jiggle or vibrate on the spot. Water is made of tiny particles too, but they have more energy. They move around and tumble over each other. When jelly is added to water, it begins to dissolve. The smaller water particles get in between and eventually separate the jelly particles. A solution is made whenever two substances mix completely into each other. But is there a limit to how much will dissolve? Salt is vital to keep us alive. It's used to make things like soap. Even toothpaste has salt in it. And, in its impure form, it helps to keep winter roads free of snow and ice. Its chemical name is sodium chloride. Worldwide, nearly 200 million tonnes are used every year. Hot countries use the weather to extract salt from seawater. Heat from the sun evaporates the water from shallow inlets, leaving the salt behind. When most of the water has disappeared, the salt is harvested. This outdoor evaporation method has been used for thousands of years, and it's still a frequent sight around the Mediterranean Sea. We simply don't have the weather for it in the UK, but luckily there are other hidden reserves. Rock salt exists in deep underground mines. It's a mixture of clay and salt. But how did it get there in the first place? These underground salt beds began forming in Jurassic times, roughly 200 million years ago. Back then, the world was a very different place. What we now know as the north of Ireland and parts of northern and central England were covered by a shallow, landlocked sea and surrounded by a hot, red, waterless desert. Over millions of years, the water gradually evaporated, leaving huge deposits of salt behind, which eventually became covered by layers of sand. As the layers built up, they became compressed to form rock. Thick beds of rock salt now lie about 300 metres below Northern Ireland, Cleveland and Cheshire. Over the years, water has seeped underground, dissolving some of the salt and bringing it to the surface. Salt water springs bubbling out of the ground were the first clue that salt deposits lie buried underneath.
Nobody knows who first found saltwater springs like this bubbling out of the ground. But when the Romans first invaded Britain, they quickly spotted just how useful these salty springs could be.
You see, Romans knew a thing or two about using salt to preserve meat, because back then they didn't have any fridge freezers, so salt became an essential preservative. Although that made everything taste a bit salty. Salty-like.
But more importantly, we need salt to keep us healthy. Every cell in your body needs sodium chloride to stay alive. So throughout history, salt's always been very precious.
Now, would you believe that in Roman times, salt was used as money? Fish and chips, please, Spadger.
Certainly.
Now, sal is Roman for salt. So the word salary comes from the fact that Roman soldiers were actually paid in salt.
That'll be £2.50, please.
£2.50, certainly. £2.50. There you go. What's up? Oh, you want a tip? Certainly. There you go, tipped it for you.
To extract the salt, the Romans had used a lead pan like this. Just heat up the spring water. As the water evaporates, salt begins to appear, and lots of it. People often say that too much salt is bad for you, but so is too little.
Bonjour! Now, thousands of Napoleon's troops were thought to have died due to a lack of salt. Pass the salt, one said, and we ain't got none, they replied. You see, their wounds couldn't heal because they didn't have enough salt in their blood. Salt production continued through the centuries, and while the evaporation method may have stayed the same,
What changed was the size of the pan! Salt became big business in Victorian times. Huge iron tanks were used for heating up the salty water. The Lion Salt Works here in Cheshire closed down in 1986. Lying derelict like this, you might think the salt industry has finally died.
But today the industry is bigger than ever. Due to modern technology, we can now separate the water from the salt in huge vacuum evaporation tanks such as these.
2,000 tonnes are produced here at British Salt every day. Behind me? Well, that's about a week's worth.
ouch! Ouch!
What are you doing?
Rubbing salt into my wounds. How? Have you got any chips?
Hey?
I've got all this salt and no chips.
Hey?
I want some chips. All this salt and no chips. I want some chips. I want some chips!
The word salt is commonly used to describe sodium chloride, but in science there are many other salts too. At a distance, these 5 salts all look fairly similar. They're all the same colour, but each is a different chemical. The 5 salts are sodium chloride, magnesium sulfate, magnesium chloride, calcium chloride, and potassium chloride. The one thing they all have in common is that all over the world, these 5 salts are present in all seawater. Different seas simply contain different amounts. So all you need are the ingredients, a recipe, and you can make your very own artificial seawater.
And that's when I realised that the chicken was still alive.
Oh, hello and a big welcome to the Crazy Cook in the Kitchen. Today we go a little daft in the kitchen, like this. He's a crazy boy. Okay, today we're gonna make for you the Atlantic Ocean. Hey, it's got a 5 salts. It's gonna be massive. And I'm gonna make the Dead Sea. It's got a 5 salts. It's gonna be dead. So, first we're gonna start off with the Atlantic Ocean, and for this we got 5 liters of water in a big pan, and we also got 17.5 grams of sodium chloride, salt. So, I also have 5 liters of water in the pan, and to this water I will add 47.5 grams of sodium chloride. Wow, that's 3 times more than what you got. So, back to my aromatic Atlantic Ocean, and for this, I'm gonna add 4.3 grams of magnesium sulfate. And now to my Dead Sea delight, I'm going to add 11.7 grams of magnesium sulfate. Hey, that's 3 times more than what you got. He's getting a bit too smart for me. I'm gonna show him. I got it here, 3.4 grams of magnesium chloride. And in my Dead Sea dream, I've got 9.25 grams of magnesium chloride. What do you know? That's 3 times more than what you got. In it goes. And whisk. Now, this next stuff is very spicy, so you gotta be very careful. And the spicy stuff in question is 0.9 grams of calcium chloride. Well, I've got 2.5 grams of calcium chloride. Here you go. Hey, that's 3 times more than what you got. So, now I'm gonna add just a pinch of potassium chloride, cause in the Atlantic Ocean there's just 0.4 grams of the stuff for every 5 liters of water. Ha! Cheapskate! I've got 1.1 gram of potassium chloride, and in it go. Hey, that's... I know! It's 3 times more than what I got. No, it's a tabletop, you buffoon. Hey!
If a tomato is dropped into the artificial Atlantic Ocean, it sinks. Take the same tomato over to our Dead Sea, and it floats. The greater amount of salts in the water make it more dense and more buoyant. In the global challenge, yacht crews work hard to sail around the world. and crossing the oceans is even harder when you're on your own. More people have orbited the planet in space than have sailed single-handed around the world. And that's just what Andy Hindley is preparing to do. He'll be spending 40 days at a time in this high-tech racing yacht. Like all humans, Andy needs a minimum of 4 litres of water a day. At sea, he's surrounded by water, but it's undrinkable. So what does he do? When he's racing, he can't take much water with him. It weighs too much. The whole point is to keep the yacht as light as possible. He takes only the bare essentials.
Welcome aboard. This is where I spend my 40 days at sea racing. That's my bed. This is my kettle where I cook. This is what I eat out of, a dog bowl. I wash up in this bucket. These are my clothes to keep me dry and my boots to keep my feet dry. Got a toothbrush. Don't really wash, but we use baby wipes to keep clean. And got a bucket, which is actually my toilet.
It's sparse but very sophisticated. GPS, a global positioning system, allows him to stay on course. A radio phone and satellite communications keep him in touch with people back home. Radar helps locate other nearby boats and prevent collisions. But what about the water?
This is probably the most important piece of kit on a boat. It's a water maker. Got a filter here, which takes in salty seawater, passes it out into here, which is pressurised, filtered again in here, and out comes fresh water through this little tube. Then we store it.
Packed inside is layer upon layer of an ultra-fine mesh known as a membrane. It's perforated with minute holes. Seawater is pushed through under pressure, but the holes are so small they only allow the water particles through, leaving the bigger dissolved salts behind. What comes out at the other end is fresh water. Without the water maker, Andy simply wouldn't be able to stay away from land for as long. Another source of fresh water at sea is rain. It doesn't always fall at the right time, but sailors have long known how to use their sails to catch raindrops. In a downpour, you don't even have to drop the sail. Another option is distillation, but it's a bit of a nuisance and takes a lot of energy to produce very little fresh water. And it just wouldn't be practical on the high seas. Imagine trying to boil water and collect the condensation in conditions like these. So, why is the sea salty? Where do the salts come from?